Okay, this first one up here, requirements for the catalyst.
It needs to help a reaction go faster, and it also needs to not be part of the reaction. Like it needs to still be there unchanged after the reaction.
Yeah. It's got to speed up the rate of the reaction and must be it's got to be present after the reaction's over. Color got washed out. What's up with that? They spent a bunch of money on these new projectors and that thing looks terrible. The one thing I want to say about this is when we're talking about the thing still being there, it doesn't necessarily need to be the same exact thing.
Does it need to be the same amount?
It needs to be, that molecule needs to be present, and that quantity of that molecule needs to be present in the same amount. But it doesn't necessarily need to be that molecule. Does that make sense?
They can take something out of another reaction.
So like if the solution is acidic, it might use acid from the solution, but when that reaction is finished, that reaction, one of the products for that reaction must be an acid. Does that make sense?
The acid bonded with the catalyst.
The acid is the catalyst. So it might not be the exact same. I mean, if we're talking about acid, you're usually talking about an H+. That thing might have been used during the reaction, but one was generated by the reaction. So the total quantity of H pluses stayed constant during the course before and after the reaction. So it doesn't need to be like the catalyst in your catalytic converter, which is a piece of platinum, and obviously nothing ever happens to it. It could be something that was there, went into the reaction, and then another one came out from another spot. But the concentration and rate of the reaction, rate needs to go up for sure, and the concentration needs to be the same for that substance, or it doesn't need to, or it can't go anywhere at all. For an endothermic reaction. All right, so energy, time. That's terrible. Bless you. Yeah, I think that's it. So you've got an activation energy, you've got the product's energy being larger than the reactant's energy. So you know that this reaction needs to have an energy input, otherwise it's not gonna keep going. What's like the easiest one you can think of? That's an endothermic reaction. There's two, you should just be like blah blah and just that's the end of it. It should always just come into your mind. Charging your cell phone, just charging a battery. Immediately, that's obviously an endothermic reaction because I'm constantly putting energy into it. The second I unplug it, it's not like I plugged it in and the battery starts charging and then I can unplug it and it just keeps charging. So the moment you stop, the reaction stops. And then the other one, the go-to is, depending on which way the question's asked, either respiration or photosynthesis. So photosynthesis is this, right? So if this is photosynthesis, then the opposite reaction, which is respiration, must not be endothermic. It must look like the one that we had in the notes, which was exothermic. So if you like plants, just think about photosynthesis and going back and forth when you get asked that question. And if you like cell phones, then think about it like that. A phone on, not being charged, is exothermic. A phone being plugged in and charged, endothermic. Or your car battery, starting your car, exothermic. While your car's running, what's happened to your car battery? It's endothermic. It's being charged. Unless there's something wrong with your alternator's broken, then you would be charging that battery. All right, so 4 factors. Give me a factor. Orientation. Give me another factor. No.
Concentration.
Concentration. Which could be pressure, but pressure doesn't dictate all forms of concentration. What else we got?
State.
State, that's fine. State or nature would be fine. I say it's not just state. State is an okay way to say it, but those hand warmers, remember that was iron in a solid state, right? It's powdered iron, and that's not the same as like a chunk of iron of the same mass, right? So we're talking about the nature of the substance. Doesn't necessarily mean just solid, liquid, or gas. It could be a solid that's been ground, or yeah, that's pretty much it. What else we got? One more thing. Temp. Okay, so then what are the three things that that are the collision theory?
To hit.
Collide.
Yeah.
What else we got? Energy. Got to hit hard enough.
And hit in the right spot.
And then hit correctly. Actually, we should write catalyst up here. All right, so the catalyst is about hitting correctly. The temperature is about energy, that they hit hard enough. And the fact that they collide will be increased by a higher concentration or a different state of matter or a different nature of the substance. Okay, so what's the automobile catalytic converter do?
It's alliance. Orients.
Let's just say it plain. I want you to think about either like a pool table or air hockey for the catalytic converter in your car. So instead of having, have you guys been to Chuck E. Cheese in the past 10 years? I went with for my nephew's birthday, and they had this thing where you went inside of it, and there was like Chuck E. Cheese money, whatever it was, flew around inside a chamber while the air blew really hard from the ground. And so you're trying to grab the Chuck E. Cheese dollars out of the air, and it's not easy, right? So that's because it's three-dimensional dollar bills going through, or whatever, Chuck E. Cheese money going through the air, and so it's hard to gauge the up, down, left, right, and back and forth. So before my nephew went in, because his friends went in first, I told him, stop, don't grab anything out of the air. Look down, see what's on the ground, and grab anything that's against the glass. He had like 100 times more Chuck E. Cheese dollars than everybody else did. Why was it easier for him? Because he removed a whole plane of dimension, right? Those things were still moving, but they were moving on a flat surface. And so he was more easily able to grab those things. So that's the easiest way to think about it.